So again, good morning, everyone. We'll go ahead and get started with our webinar this morning. Again, my name is Dan Brown. I'm one of the hurricane forecasters at the National Hurricane Center, broadcasting to you from my home this morning here in South Florida. I'm joined by a distinguished panel, which I'll introduce here in just a few minutes. A couple reminders about the webinar. One, we won't see you and we won't unmute anyone, but there is an opportunity to ask questions in the question box. So you should see a question box. I see someone has just said hi and good morning in our question box. So there is that box in which you can type questions. A couple of us will be answering those questions during the webinar, but then we'll save many of these questions for the end. And we have about an hour this morning, and about the first half of that hour, we will be giving you a presentation talking about hurricanes and hurricane hazards and how we forecast those storms. And then again, we'll have about half the time, hopefully, for questions. So we'll get right into it with our first slide. And the first slide is to show you, unfortunately, that Florida is no stranger to hurricanes. We in this state, all of us that are on this morning are from Florida, and we live here too. So it's something that we have to deal with as our families and prepare for the start of the hurricane season coming up, not only as forecasters, but again, as residents of Florida. So we go all the way back to 1992 when we look at Hurricane Andrew. That was a Category 5 storm that struck the southern part of the state, and even further back in history, there's a lot of storms that have affected Florida through the years. Then more recently, we've had storms like Hurricane Charlie and then Hurricane Wilma back in the 2004 and 2005 seasons. We had 8 storms that struck the Florida peninsula. And then more recently, we've had storms like Matthew, Irma, and then the very destructive Category 5 Hurricane Michael that struck the Panhandle. So again, as you see, it's really important that we all learn about hurricanes. We know how we can prepare for those hurricanes, and we want to teach you a little bit today about the science behind what we do. So again, very excited that you were able to join us here this morning. The next slide is going to introduce all our panelists, and so let me introduce everyone that's joining me this morning. First, we have Robbie Berg, who is going to help me moderate the questions and be helping answer questions. He is a hurricane forecaster at the National Hurricane Center. Again, there I am, Dan. And then we have John Cangialosi, another hurricane forecaster at the National Hurricane Center. He is going to do the first portion of the presentation, so I'll turn it over to him in just a minute. We have Paxton Fieux. Paxton is from the National Weather Service office in Miami. She's a forecaster there. So that office covers the southern part of the peninsula, and we work very closely with Paxton and her colleagues at the National Weather Service office. I also have Andy Latto. Andy is a hurricane forecaster at the National Hurricane Center as well. He's been actually busy looking at a system out in the East Pacific this morning that we could have formed that's even before the official start of the hurricane season. We can even talk about that later during the questions. Last, I'll introduce Jessica Fieux. Jessica is a forecaster at the National Weather Service office in Tallahassee. So like Paxton, her office covers portions of the Florida Panhandle, northern part of Florida, and they're the ones that issue the day-to-day forecast for those areas. So opportunity to talk to those folks as well. So with that, I'll turn it right over to John so we can get started with the webinar.
Yeah, thanks, Dan. Good morning, everybody. Hopefully everybody listening today is excited to learn a little bit about weather and hurricanes specifically. And again, as Dan mentioned, ask all the questions you want. We want you to get as much from this webinar as possible. Now, everybody you're going to talk to today is a meteorologist. But do you know what a meteorologist is? Well, hopefully you know a meteorologist is someone who studies or forecasts the weather for their job. And today we want to tell you a little bit about our jobs. But what I want to tell everybody, if this stuff interests you and you're good at math and science, I think you have what it takes to be a future meteorologist. So please do keep that in mind. Now, what is the National Hurricane Center and what do we do there? Well, first I want to tell you, since most of you today are listening from Florida, we're in your state. We're located in Miami, about 10 miles west of the downtown part of Miami, on a college campus called the Florida International University. Now, I wish we could be in the building today showing you around, but hopefully you get a sense of what we do throughout this webinar today. Now, here's a couple of pictures of the outside of our building. You can see them here. And when you look at that, you'll say, well, it's not a very exciting looking place. It isn't from the outside, but it is very, very strong. The building is made of concrete and steel, and it's designed that way to keep us safe so that we can work there even if a hurricane strikes South Florida where we live. Now at the National Hurricane Center, we have a really big job. We forecast for tropical storms and hurricanes over a really large area, generally from the coast of Africa all the way west across where we live here near Florida, and then into the Pacific Ocean pretty close to Hawaii. Now, in addition to forecasting hurricanes, we also have another job. We tell boaters, big ships, and other people who spend time on the ocean what the weather is going to be like. So if you go on a cruise, or you like to go offshore fishing, or if you know people that work on an oil rig, for example, we want to keep everyone out to sea safe, giving them what the wave conditions are going to be like and how strong the wind and weather conditions are like. Now, in addition to the National Hurricane Center, you might have heard of the National Weather Service. Does that ring a bell? And you might be saying, well, where is the Weather Service? Where is that located? Well, take a look at this map. The National Weather Service has a whole bunch of local weather forecast offices scattered across the country. In fact, there are 6 offices that are just located in Florida. And today we have some meteorologists from 2 of those offices. And first, we're going to go to Jessica from the Tallahassee Weather Forecast Office. And Jessica, can you tell everyone listening what you guys do at that office?
Absolutely. Thank you, John. So while the National Hurricane Center covers a huge area, we actually only cover a small area of the country. So the Tallahassee office, we have a picture on the lower left or lower right-hand corner of this image, and that shows what we cover. So we cover 48 counties across the Florida Panhandle, the Big Bend, Southeast Alabama, and Southwest Georgia. And then we also cover a marine area out to 60 nautical miles. So while the Hurricane Center is focused more on hurricanes, we also have responsibilities to be focused on forecasts and warnings, not just for hurricanes, but also everyday forecasting. In addition, winter weather, severe weather. If you live in the Florida Panhandle, you were dealing with severe weather yesterday. And then also flood events. But specifically, we work with the National Hurricane Center when it comes to those hurricane forecasts. So on one of the lower pictures, you will see our office actually standing there all staring at a screen, and you see the backs of everyone. So what we're doing in this picture is the Hurricane Center is having a conference call to tell us what their forecast is going to be, what their thinking is, and ask our thoughts on their thinking and where we should have those watches and warnings. And so that's one of the ways that we coordinate with them. But again, it's a back and forth process, working together to make sure that we keep everyone safe. So in addition to our responsibilities of forecasts and warnings, we also could embed with our emergency management agencies. So for example, in Hurricane Michael, we were at the Leon County Emergency Management Agency or Emergency Operations Center. We also were over in Bay County, which is where Panama City is, in their Emergency Operations Center to help our emergency managers best understand the forecasts and what the impacts are going to be across our area. I also want to describe a little bit of our office. Just like the National Hurricane Center is located on a university, so are we. So we're located on Florida State University's campus. So in the lower left-hand picture, you can see the outside of our building. We're on the 4th floor there. So where you see all those hurricane shutters down, that was us during Hurricane Michael. And then if you walked inside of our building and saw the operations center, you would see the picture at the top. So this is during shift change during Hurricane Michael. And so we had all of our forecasters in the office at this point. It was all hands on deck. And the day shift is sitting down and the night shift is standing up. And we're basically getting a briefing on what happened that day and what is we need to be focusing on in terms of the night shift. So again, while we cover more than just hurricanes, we do work with the Hurricane Center back and forth to keep our public and emergency managers advised on what the local impacts are going to be from hurricanes. So John, I'll send it back to you.
Yeah, thank you, Jessica. And the only thing I'll add is if anyone today is listening from the Tallahassee area or anywhere circled over here in yellow, Jessica is your go-to meteorologist. So make sure to ask her all the questions you want about weather in that area. All right, next let's go to Paxton. who is in the Miami Weather Forecast office. So Paxton, feel free to tell the kids whatever you'd like to say about what happens at the Miami office.
Yeah, so quite similar to what Jessica said. We work directly with the Hurricane Center during any tropical event, and we do much more than hurricanes. Like Jessica said, we do forecasting when it comes to flood events, the severe weather, and every once in a while we even have to deal with winter weather down here. Different standards than up in Tallahassee, but we still have to deal with it every now and then. And I'm sure a lot of you remember our infamous iguana post back in January. So for us in Miami, we have we forecast for seven counties in South Florida. Basically everything below Lake Okeechobee area, but north of the Keys. And we forecast for both coasts, both the Gulf Coast and the Atlantic Coast, out to 60 nautical miles, along with Lake Okeechobee. And then on the top left picture, you might think you just saw that building. You did. It's also the National Hurricane Center. So the Weather Service in Miami is pretty unique. We share the same building with the Hurricane Center. So it definitely makes things a little easier when it does come to tropical event times and everything like that. I mean, they're just around the corner. And in the bottom left picture, you can actually see a couple folks from the NHC over on the weather forecast side. You can see Ken Graham standing there. And in the right corner, you could see the meteorologist in charge, Pablo. They're the two main guys of that whole building. They're two very, very smart people. And then on the bottom right picture, that's during Hurricane Dorian. There's a few of the forecasters getting together, trying to figure out what to do, collaborating with neighboring offices and the Hurricane Center, trying to get everything as perfect as we can. But otherwise, very similar to the Tallahassee office when it comes to rules and everything like that.
Thank you, Paxton. And likewise, anyone listening from South Florida today, ask Paxton as many questions as you want about South Florida weather. And just to plug for the other weather forecast offices that are not represented today, there is an office in Key West that covers the Florida Keys, a Melbourne office that covers East Central Florida, the Tampa office that covers the west part of Central Florida, and Jacksonville that covers Northeastern Florida. All right, so now let's move on and show you a little bit about hurricane science. Now, when you look at this satellite animation that you see here, do you recognize some parts of the hurricane? Now, what catches your eye specifically in this animation? I bet it's the middle right here, right? That's the center of circulation of the hurricane, or the eye. In this particular case, it's Hurricane Harvey that struck Texas in 2017. Now, the eye of the hurricane is a really weird place. I say it's weird because it's almost calm and clear. That's incredible, right? How could it be calm and clear and beautiful weather in the middle of a hurricane? Well, that's a little bit about the science and physics about hurricanes work, but it's a weird place, the eye, because right outside of it is called the eye wall in this area that I'm highlighting. In that zone, right around the eye, is where the weather is the worst, where the winds are the strongest, the rain is often the heaviest, and where the damage tends to be the worst. Beyond that, in the zone around that are the rain bands that are all spiraling around the center. And in the rain bands, it could be really gusty, and there can even be some tornadoes. Now, if you take a big look, just kind of zoom out for a second, you can almost imagine that the hurricane is kind of beautiful and amazing, right? Mother Nature really does produce some amazing things. But hurricanes are certainly not beautiful if one strikes the area where we live. Now, you probably know that we give hurricanes names, but did you also know that we give them groups or categories? It's how we help communicate about how strong a hurricane is. Now, decades ago, these two men worked together to design this scale called the Saffir-Simpson Hurricane Wind Scale. Herb Saffir was an engineer and Robert Simpson a meteorologist that worked together to build a scale that showed you how strong the hurricane was only based upon the winds. So it does not include rain, storm surge, and other hazards that we're going to talk about. where Category 1 hurricanes have winds in this range, 74 to 95 miles an hour. And then the wind speeds increase as the categories go up. And by the time you get to the worst one, a Category 5, the winds are 157 miles per hour or stronger. So just these incredibly powerful winds. Now, I want to talk about and show you where these really strong hurricanes go. We call them major hurricanes, and they're Category 3s, 4s, and 5s on the scale. So where do those really strong hurricanes go? Let's take a look together on this map. Each one of the lines you see here show you the path of a different major hurricane. Where the lines turn yellow, it shows you where the hurricanes were when they were at their strongest or near their peak intensity. Now, I want you to focus on the yellow portions of the lines. Where are all of those yellow lines or the major hurricanes? Well, let's take a look together. All across the northern portion of the Gulf of Mexico, right across South and Central Florida, the Bahamas, and the Western Atlantic. This zone that I'm circling right here is the area that we know of in history where they have seen the strongest and most damaging hurricanes. And guess what? A lot of us today live in that zone. But the bottom line here is, everybody, is if the water temperatures are warm, generally around 80 degrees Fahrenheit or warmer, hurricanes have an opportunity to affect the area where you live. So certainly in Florida, the waters are plenty warm enough. But the waters are actually warm enough even near the coast of Canada, way up north. So we share the pain of hurricanes with a lot of others across the basin. But since most of us today are listening from Florida, let's take a look at a little history of hurricanes just for our state. Now, each one of the lines show you the path of a different hurricane. And wow, what a mess, right, everybody? It goes to show you how many hurricanes we have in Florida history. Where the lines are purple and red shows you where the storms are really strong. And where they're green or blue, it shows you where the storms are weaker. But the bottom line, everyone, is that we live in a very vulnerable or hurricane-prone place. So we need to be hurricane ready. In fact, we need to be more ready than everyone else in the country because we get hit more than every other state. So I'm counting on you to get ready for hurricane season. Speaking of that, let's test your hurricane knowledge. We're not going to just let you sit there and relax entirely during this webinar. We want to see how smart you are on hurricanes. Are you ready for your first quiz? Now, once I finish reading this question, you will have a chance to select what you think the correct answer is, and then we're going to go over it together. Here is your first quiz. When is the Atlantic hurricane season? Do you think it's A, May through November, B, December through April, C, June through November, or do you think it's D, hurricane season is all year long? All right, everybody, the poll is now open. Please select your correct answer.
So vote in the box that pops up. I know we've had some folks answer in the question box, but you should see a poll that you can answer. I see the votes coming in now. And by the way, there are lots and lots of great questions. It's hard to keep up with all the questions that are coming in, so keep them coming. I know we're not going to get to all of them this morning, but we certainly will try to get to as many as we can. And there's a lot along the same themes, which is good. So we'll definitely answer some of those questions. Give it a few more seconds here on the votes to come in. I'll go ahead and close the poll. Let me share those results. So I don't think you can see them, John, but it looks like about 60% said June through November, with another third saying May through November.
All right. Well, thanks for that, Dan. So it sounds like the majority got this correct. Let me reveal the right answer. It is C, June through November. But you know, Dan, the other part that said May through November, that's really close. Sometimes we do get tropical storms and even hurricanes in the month of May. So way to go, everybody. Sounds like, and I'm not surprised, but it sounds like the Floridians know what hurricane season is. All right, now hurricane season, as we just mentioned, is officially half of the year, June 1st through November 30th. But at some parts of the year, it can be incredibly busy and the tropics really come alive. And I want to show you how busy it can actually get just in the Atlantic Basin when we get near the season's peak. This is from a couple of years ago. And at this one day, we actually had 5 different weather systems that we were walking across the tropics. We had Hurricane Florence over here in the Western Atlantic that went toward the Carolinas. Tropical Storm Isaac over the Central Atlantic that moved into the Caribbean Sea. Hurricane Helene here over the Eastern Atlantic. Another system that became a tropical storm here near the coast of Africa. And another in the Gulf of Mexico that went on to affect Texas and Louisiana. It just goes to show how busy it can be. And unfortunately, every hurricane season at some point gets pictures that look somewhat like this. Now you might be saying, well, when is this busy period most likely to happen? Well, let's take a look at climatology of this campfire looking graphic, or when we typically see the most hurricanes. Now, whether you look at the red area, which shows you hurricanes and tropical storms together, or the yellow, which is hurricanes by themselves, you get the same answer. You see that? The peak occurs right here in the middle portion of September. And the bottom line is, of those 6 months of the hurricane season, there are 3 that we want you to be the most ready. And those months are August, September, and October. So get ready for the whole season, but be most on guard for the late summer and fall months. That's when hurricane season really ramps up. So don't be too surprised if June and July get off to a quiet start, because that's what usually happens. All right, you ready for your next quiz? Now for this one, everyone, we're not going to ask you to vote like you did before. We just want you to think of the question and scream out the answers in your house. Or if your parents are telling you to be quiet, maybe just whisper. Are you ready? Here is your quiz. What are the primary hurricane hazards? Do you think the right answer is A, high winds, B, storm surge, C, heavy rainfall, D, dangerous surf along the beaches, or do you think it's E, all of the above? Okay. I'm going to give you just a couple seconds to finalize your answers. The correct answer is E, all of the above. Congratulations if that's what you were thinking. But you know, if you picked any answer in this case, you're wrong. All of these are important hazards. And since there's so many of these hazards to remember, we came up with a word to try to make it easy for you. The word that we're using here is called swift, where the S in the word swift stands for storm surge. Now, Andy's coming up after me, and he's going to tell you how storm surge works. But for now, just know this is the water that comes in off of our oceans and floods neighborhoods where we live. The W stands for wind. Of course, it's windy in hurricanes. We know that, so you probably don't need to remember that one. The IF stands for inland flooding, which could be a huge deal when hurricanes are moving slow. And the T stands for tornadoes. Hurricanes can help produce tornadoes. Of course, you could see tornadoes outside of hurricanes, but it's just another hazard that we forget about when it comes to hurricanes making landfall. In addition, one more hazard that is not that word are the waves currents. And what I want to let is, even if a hurricane doesn't affect the area where you live, you could still get big waves and really rough conditions along the beaches. So remember to pay attention to the local meteorologists like Paxton and Jessica when it's a good idea to stay away from the beaches. Let's do another hurricane quiz. I hope you can do as well this time as you did last time, but this one's a little trickier, so get ready. This one, we are going to ask you to vote. Get ready for that pop-up that appeared like before that Dan told you about. Are you ready? Here we go. Which hurricane hazard that we just talked about has caused the most deaths in the United States? Do you think the right answer is A, wind, B, storm surge, C, flooding, or D, tornadoes? Now I see the polls open, so select the answer that you think is correct, and from here I'm going to let Andy talk about what the correct answer is.
Thanks, John. The poll is open and lots of folks are answering. I think we got more folks answering this time around than last time, so I hope everybody sees the box. Maybe more people are paying attention now. Give a few more seconds for those votes to come in. It's a really close race here, so those votes are going to matter on this one. Let me go ahead and close the poll and share those results. And so, Andy, as you get started here at the second half of the presentation, it was a pretty close vote here. Flooding edged everyone out with 37% of the responses. Storm surge was second with 32%, and tornadoes with 23%. And last is wind with only 8%. So with that, I'll turn it over to you, Andy.
All right. Thank you, Dan. So the correct answer to the question, so the flooding and storm surge were very close, and you folks are on the right path here. The correct answer actually is storm surge. So I grew up in West Central Florida, and actually my brother and his son Jackson are on the line right now watching this webinar. We grew up a few miles inland, and we're up about 30 feet above sea level. And so when storms approach, we thought mainly about the wind hazard because the winds can cause fatalities, and it can be very strong and cause a lot of damage. As you can see from these pictures here, it tore a building apart, and it can potentially blow a 2x4 right through a tree if the winds get strong enough. So it can be very damaging, very deadly. A lot of folks think about wind, but water is what a lot of people don't think about and what really should think about. That is the deadliest part of a hurricane. The top left-hand corner, you see folks being rescued from water due to flooding rainfall. The bottom left, you see flooding happening from storm surge, the water moving inland from the coast as a storm moves on shore. So yes, water is what kills in a hurricane. Storm surge accounts for nearly half the fatalities from a hurricane. And I'll explain why here in just a minute or two. Rainfall, flooding from rainfall accounts for another 27%, and other water-related fatalities can be caused by rip currents or offshore fatalities such as drowning in a boat. So, but wind and tornadoes can also be fatal in these storms. So we talked about storm surge. I'm going to show you an example from Hurricane Sandy. Hurricane Sandy was a very large hurricane that made landfall up in the New England area back in 2012. And this is what Manhattan looks like on a typical day. Folks are walking around, there's vehicles driving around. Pay attention to the storefront here. When Hurricane Sandy made landfall, water rose a few feet up on that storefront into the city of New York. So you can see the water here in this van, about 3 feet high, and water's most of the way up in this car. Folks were probably trapped inside these buildings as the storm passed. Storm surge can be deadly because if you do not evacuate, the water can enter your home. So you can't protect yourself in your home. In this case, for Hurricane Sandy, these houses were closer to the coast. Imagine yourself at the beach in a few foot deep of water, and a 3-foot wave hits you. It can knock you over. Water is very heavy. Water is very dense. Moving water and the waves pounding on top of that water can easily move homes off their foundation, like it did here during Hurricane Sandy. And if you're not evacuated, you're putting yourself at risk if you're in an evacuation zone and that water can enter your home. We talked about flooding rains, another big cause of fatalities in hurricanes. So when I talk about flooding rains, we're talking about heavy rainfall, persistent rainfall, and what happens is the water tries to run off into the ditches, the rivers, and the lakes, but they can't handle all of that water. So the water has to go somewhere else. This example actually was from a system that never became a hurricane. It was Tropical Storm Allison in 2001 that made landfall near Houston, Texas. This is what happened when the rainfall had nowhere else to go. It filled up the Interstate 10 corridor. In fact, this water is several feet deep. Look at these semi-trailers. The water is several feet deep in this area. And so what happens is that why flooding rains can be so deadly is folks enter the waters or drive into areas that are flooding, and those cars can get washed away if those flooding waters are moving along. What also can happen is if you live in a low-lying area that's prone to flooding due to rainfall, the water can rise up in your home and might trap you inside. We talked about tornadoes and waterspouts. So the difference between tornadoes and waterspouts is that waterspouts are over water. In the bottom left-hand corner, this is over water. This one up here is over land. Well, this is becoming a tornado. The water spout was over water on the right, and now it's moving over to the land. So that's the difference between those two. And yes, they do occur during hurricanes. We talked about waves and rip currents. We mentioned that a storm could be a few hundred miles offshore. There could be a storm in the central Gulf of Mexico. It could be a sunny day at the beach in the Tampa Bay area, for example, and there could be dangerous rip currents, because what the storm does is send these swells away from the storm, far away from the storm. They can reach the coast, they break along the beach, and when you've seen it, if you've been to the beach, waves break and the water recedes. Well, all that receding water can create channels. So you see the bottom left-hand corner of your screen here, it creates a channel in the sandbar, and you could potentially get stuck and pulled out into the deep waters away from the beach if you get stuck in it, and that's what we call a rip current. Now, the folks at the weather forecast offices can issue a rip current statement to try to give you a heads up that these conditions could be in place, and you might not be aware of them because the weather's just so nice. Some of the beaches do offer the beach warning flags as well that you see in the center here. When you have yellow and red, it's trying to tell you that, yes, the conditions might be hazardous and you might want to avoid going into the water that day. So we talked about hurricane hazards. How do we predict these things? How do we know where they're going to go, how strong they're going to be, how big they're going to be? Well, we first start off with all of this information that's coming in through observations. We have observations over land at weather stations. We have ships that relay data from over the seas to us. We have buoys over the seas as well. We have reconnaissance aircraft that fly into the storms and around the storms that can provide us helpful data. We have upper air data from weather balloons. Those are launched from a lot of the weather forecast offices across the country that can give us an idea of what's going on in the environment across the area that could potentially steer or affect the storm's intensity. Satellites, we have satellites in outer space. The bottom left-hand corner picture shows you, and John showed you a picture of Hurricane Harvey. Satellites will take snapshots very frequently of a storm, and you can see the structure of it. You can see where it's moving, and you can actually get an intensity estimate from looking at the satellite pictures. If the storm's close to the coast, we have Doppler weather radar. You can see in the bottom right-hand corner here, it actually sends a signal into the storm that helps us see the structure of the storm as it approaches. And actually, the people at the weather forecast offices can track tornadoes in the hurricane as the storm makes landfall. Most of this data that I'm talking about all gets pulled into these very sophisticated computer models on supercomputers that try to simulate where the storm's going to go, how big it's going to be, and how strong it's going to be. At the Hurricane Center, we're looking at all of this data, we're looking at all these computer models, and we're trying to decide what the best, most likely scenario is for the storm based on the data we're looking at. I mentioned we fly airplanes into hurricane. That is correct. So we have several aircraft here on the screen. The top left-hand corner is a NOAA aircraft. It's jet propelled. It typically flies around the storm and it samples the environment above and outside the storm to try to determine what the steering flow might be and what other environmental conditions such as water vapor and wind shear might affect the storm intensity. The aircraft over here is another NOAA-owned aircraft. We have a couple of those, propeller powered. This actually flies into the storm itself. Just like the Air Force owned one down here, there's several of those aircraft in existence. They all fly into the actual storm to sample the structure of the storm. They do drop sons, which is an instrument they drop into the storm and it splashes down in the ocean. You can find out the wind speeds at the surface in various locations of the storm. They also have instrumentation on the aircraft, even radar on the aircraft that can tell us what's going on as the aircraft's going through the system. And they do fly into the eye of the hurricane. On the right-hand picture here, this is actually a view from the center of the eye of a hurricane. What you're looking at, as John mentioned earlier, is that the eye can become somewhat eerie and calm. There's a lot of sinking air going on, and that's how they're structured. There's sinking air in the very center, and so the clouds are very low, if there's clouds at all. You might actually be able to see the water at times in the eye. But you look towards the edge, this is the most violent part of the storm, the eye wall. And when you're in the center of the eye, it almost looks like you're in the middle of a football stadium looking up at the stands. And the stands are the eye wall. That's what we call the stadium effect. When there's a storm approaching, you're going to see a glimpse here of what the Hurricane Center looks like inside. On the left-hand side, there's folks giving interviews to television crews that show up when the storms are approaching. Behind that, these people doing these interviews is the hurricane specialist unit that we work and do the forecasts for these tropical cyclones. What we also do is we take phone calls for folks doing radio interviews and the newspaper as well. We also post social media on Facebook and Twitter and YouTube for some additional information about the tropical cyclones. We also have our website, hurricanes.gov, that can provide information as we issue new advisories for the storms. Now, this slide I'm showing you here, we have Hurricane Preparedness Week coming up in 2020, coming next month. So you might have questions such as, well, am I in the evacuation zone? What kind of supplies should I get to get ready for the hurricane season coming up? Where can I go to get additional resources or the latest information? This is a one-stop shop that will tell you how to find all that information. It's weather.gov/WRN/hurricane-preparedness. That link's at the bottom of your screen. And I can backtrack to that here in a few minutes once we're answering your questions for everybody. Oh, it's actually on the bottom of the screen now. So thank you everybody for joining us. For the next 20 to 30 minutes, we're going to be answering the questions you folks have been asking. And we're going to have Dan and Robbie field those questions for us now.
Thanks, Andy. A very great presentation. I don't think we've seen so many questions come in as we've seen on this webinar. There are lots and lots and lots of questions. So it's going to be hard to get to all of them, but there's several on various themes. And there's been a lot asking about the naming of storms. And I think, John, you mentioned it when you were talking, so I was going to throw this one over to you. I saw both a lot of questions, one from Anita about why do the hurricanes have different names, and then one from Zachary saying, who's responsible for actually creating those names?
Yeah, good questions, Anita and Zachary. So why do we give them names first? We give them names to help communicate about them. I don't know if you remember that satellite picture I showed you where it had like 5 different storms at one time. So it's much easier for us as people to recognize names and associate with them. So if we knew it was Hurricane, for example, Hurricane Andy and then Hurricane Dan, we can then place those hurricanes with different areas and threats. Like we might only have to worry about Hurricane Dan and not Hurricane Andy, for example. So that's why we give them names to communicate about them. You might notice about the names that some are boy names, some are girl names. They're rotating lists. You might also notice about the names that they come from different backgrounds. Some are English American, some are French names, some are Spanish names, because those are the countries that get affected by hurricanes across the Atlantic Basin anyway. Now, if you want to see what the names are for 2020, you can go to hurricanes.gov, that first link you see there, and you can actually search for what the names are. The names repeat every 6 years. However, if a storm is really bad, like Hurricane Michael was or Hurricane Irma was, those names will then be retired, and the World Meteorological Organization, a whole bunch of countries come together, and part of the reason they come together, one item, is to then replace those names, so we retire the storms that were really bad for sensitivity reasons. So hopefully that helps answer your questions a little bit.
Hey, thanks, John. So yeah, we got a lot of questions. I'm trying to find the best ones. I'm going to pass the next one, I think, to Jessica, because this one's really important. So London asked, if you don't live near a beach, lake, or river, can your house still flood?
You can still get flooding if you don't live near a beach, lake, or river. So just from heavy rain coming down, you could get flooding in your neighborhood or your area. And so it's always good to know, and no matter what your plans are for a hurricane, if you live in an evacuation zone, be ready to go and everything. But even if you don't live in an evacuation zone, it's still good to have stuff ready to go in case you do need to leave unexpectedly.
Thanks, Jessica. I have a question here I'm going to send over to Paxton. I know the local forecast offices do launch weather balloons, and you all launch those at our office there by the Hurricane Center in Miami. And Lauren asked, how do the weather balloons not pop? So I'll let you answer that one.
Well, to begin with, they are very big balloons. They're not your average balloon that you buy from Publix. They they're basically as tall as me width-wise when we initially blow them up, and they are with a thicker latex. It's a biodegradable latex. So it's on the thicker end, so it can withstand lots of wind, it can withstand lots of pressure. So they're very hard to pop unless you poke it with a needle or something. But otherwise, as they rise up in the atmosphere, they continue to expand, and eventually they could get to the size of your regular classroom. They expand very, very big, and they get to a thickness as thin as a piece of hair, even thinner. So they get very thin, and once they get high up in the atmosphere and there's so much pressure within the balloon, it eventually pops. But most of the time they get well above 100,000 feet. So when they do pop, they're very high up. But down at the surface, they're pretty tough to pop. Personally, I haven't popped one yet, but still plenty of time for that to happen.
Yeah, thanks, Paxton. Yeah, so it's always interesting since Paxton was talking about earlier that we are in the same building as her office, and they launch the balloons out back twice a day. So we always get to watch the balloon lift up going over the turnpike. So that's always fun to watch. Next question I was going to send to Andy. One of the first questions we got this morning was from Jeffrey, and he asked, where do hurricanes originate?
That's a good question. There's a lot of different ways hurricanes originate, but in the Atlantic Basin, typically they originate from what we call tropical waves. And those are disturbances that come off the coast of Africa, that form over coast of Africa. And during the peak of the hurricane season, those disturbances can quickly turn into tropical storms or hurricanes as they cross the Atlantic Ocean. That's where you see those long track storms that everyone's watching for a week or two. Sometimes they take longer to form. They form the Caribbean Sea, or they may reach portions of the Gulf of Mexico and form later on. Other sources that it can form from, though, are like cold fronts. A cold front stalls out, let's say, over the Gulf of Mexico. All these thunderstorms over time can organize and turn into a tropical storm as well. Last year, we had an interesting one, Hurricane Berg. It was a thunderstorm complex that crossed the central part of the United States, emerged over the eastern Gulf, moved west, and then turned into a tropical storm. So the key is there's always these pre-existing systems of storms, clusters of thunderstorms, we call them disturbances, that can turn into a tropical storm or hurricane. You could even have them develop from systems that are formed from upper level disturbances, believe it or not. And Hurricane Joaquin was one of those examples that happened a few years back.
I was muted. Thanks, Andy. I was going to have a question here for Jessica. Someone was asking from Emma, and I know you've had some hurricane experiences in the Tallahassee area in the last few years. So they're asking, do you stay there when a hurricane is coming?
So personally, I do. Most of Leon County is not in a hurricane evacuation zone. The very southern portion of it is in a hurricane evacuation zone. So first off, we want to make sure you know whether you're in a hurricane evacuation zone or not. But personally, I stay. We go to work and we make sure that we're in a safe building. We have hurricane shutters to keep us safe. We also have a safe room, so if there was a tornado headed towards us, that we could move in there. And we also have the backup plan to go into the basement if we need to also. So we stay, but we do it in a safe manner.
Okay, thanks, Jessica. Next question, I'm going to think this one was from a teacher. It's Michael, and he was saying that he wasn't sure if all the kids really understood how important or how dangerous storm surge is. So John, I was wondering if you could explain a little bit more about storm surge, what it is and why it's so dangerous.
Yeah, so storm surge is really dangerous. So let's see if we can give it a shot to help explain it. So first, how does storm surge work? So storm surge works because let's just think Florida, for example, right? Because most of us are living in there that we're talking to today. So Florida is like a peninsula surrounded by water. So you can imagine a hurricane's coming, right? It's very windy. It's using those strong winds to create all of this stress on the ocean. It's pushing all of that water. So when it's pushing that water, where's the water going to go? It's eventually going to come to the land where we live. And since so much of the Florida population is right near the coastlines, guess what? It's unfortunately going to flood neighborhoods where we all live. Now, some parts of the state of Florida are more vulnerable or get worse storm surge than others. And a lot of the Gulf Coast, if you're listening to us today from the Tampa area or from Southwest Florida or from the Florida Panhandle, that zone in particular is really vulnerable because the Gulf of Mexico is sort of the shallow area of water that has less of a problem pushing the water inland. So just know that most of the work for storm surge is coming from the wind. And as Andy showed, unfortunately, most of the people that die in hurricanes drown from the storm surge flooding. Just remember, as Jessica said, pay attention to if you live in an evacuation zone, because those evacuation zones are connected to your storm surge risk.
Thanks, John. I have seen that we have people not only on from Florida. I've seen a few folks comment that they're from California, New York, even Tennessee. So there was one question here about what was the worst hurricane in California. So I can answer the first part, and I'll maybe throw it over to Andy to tell you about why we don't have big hurricanes in California. But if you go all the way back to 1939, there was a tropical storm that approached the southern part of California, brought a lot of rainfall and unfortunately some fatalities to Southern California. It's very rare that we get storms that far north off the west coast of the United States. And I'll let Andy tell you why that is.
Right. So you might wonder, okay, so California, that's pretty far south compared to like New York. And so the way it works is that ocean currents are really so it's a sea surface temperature issue. These storms do not like temperatures, like John said, much below 80 degrees. And so the currents of the Pacific Ocean, they rotate typically clockwise. So you picture by the time the waters get around to California, the west coast of the U.S., they're moving from the north to south. And so that's bringing cooler waters down towards California. The opposite happens in the United States East Coast because that same clockwise motions bring warm waters from around the Gulf of Mexico, around Florida, and all this Gulf Stream waters up further up the coast. So storms can occur much further north on the East Coast than on the West Coast.
Hey, thanks, Andy. Next question I'm going to send to Paxton. I think everybody seems to have tornadoes on their mind, I guess because we've had so many across the Southeast and the Midwest lately. So I guess the questions from all the kids are, how do tornadoes form? And I guess specifically, how do you see them in a hurricane?
So tornadoes form, normal tornadoes anyway, form when you have a cooler, drier air mass, usually a lot of times from Canada, and it's over the central U.S. region, and then you have moist, warm air from the Gulf of Mexico. And these two air masses, they eventually collide with each other. And when they do, you get a lot of upward motion. You have vorticity, which is basically just rotating winds, and they start to tilt upwards. And once they tilt upwards, you see tornadoes, you see funnel clouds. So that's the basic way of how tornadoes form. When it comes to hurricanes, you usually see them in the rain bands. You don't normally see them in the eye walls. It's the rain bands, so bands on the outside of the hurricane. For us in Florida, we see them a lot with the outer rain bands. South Florida too. They're not the easiest thing to forecast for, especially in South Florida. There's times where our radars, it's very hard to see the actual rotation going on. So we're looking at it with a fine-tooth comb. They're not like the strong tornadoes you see in the plains or even the panhandle of Florida. But in hurricanes, they're at the outer rain bands.
Thanks, Paxton. There's so many questions. It is so hard to find some of them that you wanted to ask in our big list here. But there was one here that I really kind of liked and was going to turn this really maybe over to everybody for a real short comment. Jennifer was asking, what do you like to do the most with your job? So I'll start with Jessica and we'll kind of work our way around. And for me, I like the fact that the weather's always changing. There's always something new and different to look at every day, and the fact that what we do helps people. So that's really my favorite part of the job. Jessica?
I would say that my favorite part is working with the partners and the public. So when we actually get to speak with our emergency managers about a weather event and give them the information they need to make the best decisions. And then also the outreach events. So, typically we get to go into schools and talk to students about what, they need to do to prepare and weather in general. And I love that part of the job too.
Robbie?
Yeah, I mean, I've always been fascinated by, what the Earth can do. And I love to travel. I like to go see nature, and just weather is just one of those aspects that it doesn't matter where you are, there's weather. So it's really cool to just watch the weather, watch the sky, and see what's happening. So I just love being able to do that in my job. It's almost like a hobby.
Andy?
Kind of like what Robbie was saying, yeah, you have something you have passion for, to be able to sit there and try to forecast what's going to happen with it. These tropical systems out there. Even back when I worked in Ohio, is to see the thunderstorms develop and try to forecast the thunderstorms. It was really exciting. So that's to me is the best part of it. But I do actually just about equally like doing the outreach part too. And because of what's going on in the world right now, this is our outreach. This is our outreach right now. This opportunity right here is something I love to do.
Paxton?
Yeah, pretty similar to everybody else. Another passion of mine is aviation, and you can't do aviation without dealing with weather. So they're hand in hand with each other. So I love being able to deal with both. The weather service forecasts aviation meteorology every single day. So I love doing that. And at the end of the day, I also like that we're able to help people out to the best of our abilities, and that's a good feeling too.
John?
Muted,
you
I'm
might be on
sorry.
mute. Oh, there you go.
I got it now. Great question, Jessica. I think just to give a different answer than everyone else, I think that every day is different in the world of weather, right? I mean, every day is a new challenge. Every day is a new learning experience because the weather is always changing, as Robbie mentioned. And one of the things about weather is it's really hard to get it exactly right. So we're always still learning. And every year, every day, I think I learn something new.
Robbie, I'll turn it back to you for the next question.
Yeah, thanks everybody. So before I ask the next question, actually there was one question I had from Jarrett, which I already answered in the box, but I wanted to bring it back up. He was asking, when was the latest hurricane to make landfall in Florida during the year? And I think this is an important question because it shows why hurricane season for us in Florida is so important. So the latest hurricane to hit Florida was Hurricane Kate in 1985, made landfall on November 21st. And actually, Jessica, that was in the Tallahassee area. And we've also had a hurricane make landfall in Florida in June 9th, Hurricane Alma in 1966. So again, remember we talked about earlier, hurricane season runs from June to November, and we've had hurricanes hit Florida in all months between June and November. So that's why we have to be ready at all times of the year. The other question I was going to ask to everybody actually on the panel, it's kind of a two-parter. We already answered part of Kevin's question about why did we choose meteorology, but Savannah was also asking, what degrees do we have to get in school in order to become a meteorologist, whether it's at the National Weather Service, National Hurricane Center, or even as a pilot as a hurricane hunter? So I think first I'll send it over to John, and then we can go around the panel if something hasn't been answered already.
Okay, sure, Robbie, I'll start. So you do need a degree in meteorology. A lot of schools across the country have it. And if you're in Florida, Florida State, a lot of people, I didn't go to Florida State, but a lot of people that you're talking to today did. The University of Miami, there are other choices all across the country, for example. So a degree in meteorology that is going to require quite a lot of math and quite a lot of physics. So hopefully those subjects don't bother you too much. But if you are interested in meteorology, it's very much worth it. And also it would pay off to learn a little bit about other subjects, but I'll leave that for the other members of the panel to discuss.
Anybody else want to jump in there?
I could chime in real quick. So the other term for meteorology degrees, they call it atmospheric science. So some schools might list it as atmospheric sciences. Like John was saying, there's other side parts. Like I had a minor in computer science when I did that. And a lot of things we do here at the office require programming, and you can actually, there's people that are full-time jobs, several of them that are at the Hurricane Center. That's what they do, is they program. And if anybody else wants to chime in other side degrees you could have like a minor in, feel free.
Yeah,
I think
I
also,
know. Oh, sorry, Jessica.
go ahead, Paxton.
I know a few of my friends, they also have minors in geography and oceanography as well, to kind of correspond with the meteorology major. And I know at Florida State, I don't know about other schools, it's probably pretty similar, but at Florida State, since there's so much math involved, you get a math minor automatically with your degree. And then there's also so much physics involved. And if you take one more physics class, you get a physics minor as well with it. So like John said, there's a lot of math, a lot of physics associated with it, but it all builds off each other. You understand how hurricanes work, how other weather phenomena work. So it's all worth it.
I'll just add, besides some of the math and science, that anymore, and John may have touched on this earlier. I was reading some of the other questions, so I wasn't paying all the attention to you, John. But is the communication side. We do. If people did not hear the forecast, weren't able to take those preparations, it wouldn't help very much. So I know I always tell my kids, I have a son that's in 5th grade and a daughter that's in 9th grade, to practice their communication skills and be able to explain things very easily to someone, because it's going to come in handy no matter what their job is in life, to be able to explain what they do and why it's important. So practice that as you're moving into middle and high school. Take all the advantages you can to practice presenting in front of people and trying to communicate very effectively. Anyone else? Let me take the next question. I know we're getting real. Oh, go ahead, Jessica.
I was going to add also that if you're truly interested in meteorology, reach out to a meteorologist in your area and try and, video chat with them or eventually shadow them for a day. And especially as you move into high school, even see if you can volunteer with them. And that's a good opportunity just to get experience and see how you like it.
That's a great point, Jessica. And a lot of the meteorologists that I know that work for the Weather Service and even broadcast meteorology are usually very, very open to having folks talk to them, meet with them, come see what they do. So that's a really, really great idea. Glad you mentioned that. I have a question here. I know we're getting really close for time here, only a few minutes left, but I've seen quite a few questions talking about the upcoming hurricane season, and we're just a little more than a month away from the hurricane season. It's a time when we all should start thinking about how we would prepare for this season. But one of the questions from Hudson I thought was really good. It asked, how do meteorologists determine whether or not a season will be active? And there are some forecasts out for 2020. The NOAA hasn't released it, but how is it that we know? And I'll throw it over to John maybe to start, and maybe Andy may want to contribute too. But how are those seasonal forecasts made? And I know we have some folks at the Hurricane Center that are on the team with the Climate Prediction Center that help make those forecasts. But I'll throw it to you, John.
Sure, thanks, Dan. Yeah, great question. Everybody is always looking forward to what the season's going to be like. And there is a team, as Dan mentioned, that work on trying to predict what the season will be like. So they look at some large things, like what are the water temperatures like? Andy and I mentioned earlier, they generally need to be warm, around 80 degrees or warmer. And sometimes we can look to see if the waters are running warmer than normal or cooler than normal. And that can give you an idea if there's more or less fuel for hurricanes to form and strengthen. Another thing we can look at is how much moisture has been in the atmosphere. Has it been drier or more moist than normal across the Atlantic basin? So if it's more moist, then hurricanes could be more likely to form, for example. And also we look at how much wind shear there is over the basin. If there's been a lot of wind shear and we think it's going to continue, then there could be less hurricanes. That could actually be bad for tornadoes. There could be more tornadoes, but less hurricanes. But if the wind shear looks light, like all of the winds high up in the atmosphere look light, then there could be more hurricanes. One thing I will say about the forecast looking forward is that the season, even though they make predictions if it's going to be busier than normal or quieter than normal or about normal, we never really know where they're going to go. We never really know how strong they're going to be. And even the predictability of those seasonal forecasts aren't great. So when it comes to preparing, I want everybody to prepare the same way regardless of what the seasonal forecast says. Simply just get ready and let's take them one at a time. I think that's the best advice.
Hey, thanks, John. I guess maybe I'll ask one more question because I think I found one that was pretty important that I wanted to cover. And then Dan, I'll send it to you when we're all done. Maybe I'll send this one to Andy. Mackenzie was asking that, if you're told you need to evacuate from your house, how far should you evacuate? Because I think everyone sees the pictures on TV that when hurricanes threatening Florida, everybody's rushing out of the state to go to Georgia and the Carolinas and so forth. And so really, how far should people evacuate?
All right, Robbie, it's not always necessary to join that giant crowd trying to drive out of the state. For example, if you have someone that just lives across town that's not in an evacuation zone and they have the space and are willing to accommodate you to evacuate, you can just do that. That way you're only a few miles away. There's other places, a lot of times shelters are set up as well in your local area, and you can look up online and try to find out from your local officials where those are.
Thanks, Andy. I think we're about out of time. I do see someone that keeps asking about a shout out for someone's birthday, so I will say happy 10th birthday to Miles out there. I did see Amy mention that her birthday was near the peak of the hurricane season, so thanks for throwing those shout outs in. And also throughout the presentation, saw a couple people say go Noles and go Gators, so definitely a Florida crowd here on this morning's webinar. I really do appreciate everyone taking the time to join this morning. Sorry we couldn't get to every single one of your questions. There were lots of them. Thanks for sending them in. Again, hope you enjoyed it. And again, I can't say enough to say appreciate you guys joining today. I don't know if anybody else has any final words that they want to say before we sign off.
Yeah, Dan, I was just going to mention real quick that we're uploading all of these webinars to the National Hurricane Center's YouTube channel. It's www.youtube.com/NWSNHC. So you can go back and rewatch this webinar or any of the others that we're doing in this series.
Okay, thanks everybody. Have a great day.
Bye, everybody.
Stay safe, everybody.